Hey everybody. So today I want to go over the assignment over a distance formula, and if you look on Google Classroom, it's just called 1.3 Distance Formula Practice. So yeah, I figured we'd go over a few of these and hopefully answer any remaining questions you may have. So anyway, we're going to do a few of these. So number one, the big thing is make sure we have the formula down. So it's going to be distance equals x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Now, a few things. One, this is basically telling us the distance between 2 points is this distance. Well, let me say it better, put it better this way. You can almost think of this as the Pythagorean Theorem, where this is the c value. This is the distance between the 2 points, and this is kind of like the x and y values combined together to give us that diagonal value. I'm not doing a good job of explaining it. Basically, if you think of a right triangle, right, and those two legs of the triangle, we're using their relationship in order to find the longer leg, right, the hypotenuse of said triangle. And it'll make more sense, I think, when you see it visually for the later problems, but yeah. Anyway, let's see how this goes. So we're going to take the x1, y1, x2, y2, and we're going to plug in this formula, and it'll tell us the distance between these 2 points, okay? So first things first. Oh, by the way, some people like to write as x1 minus x2 and y1 minus y2. It doesn't matter. It actually doesn't matter. So x1 minus y1, and we'll call this x2 minus y2. Okay? We're going to go ahead and plug these in. So d equals the square root of x sub 2 is going to be our 0. So I'm actually going to do this color-coded, the first one, just because I think it'll be a little easier to follow possibly. So x sub 2 is 0. And minus, and our x sub 1 is negative 6. Oh good, we have a double negative already. Cool. That's a good thing to have, actually. And then this should be in black. There we go. Plus, and our y sub 2 is going to be negative 6, yeah. And then minus our y sub 1, which is negative 3. Okay. That's squared. Okay, so here's the thing. There's a lot of negative signs here. Let's just make sure we did this right. I always like to double check when something like this many negatives here. So x2 is 0, yep. Minus, yep. X sub 1 is negative 6, yep, that's good. Our y sub 2 is negative 6, yep. Minus, yep. And the y sub 1 is negative 3, good. Okay, so we didn't mess up. That's good. All right, so let's get rid of all these double negatives. So when you're subtracting a negative, you're actually adding something. So we're going to change it to a plus sign. We're going to change it to a plus sign. Then we're going to rewrite it. We're not just going to be lazy and put a big plus sign there for a few reasons I won't go over. But yeah, we're going to rewrite it. So 0 plus 6. So you can see the step. You can see how you went from here to here. And then negative 6 plus 3. Okay? It's important to show that step when you're starting these out, especially. I still do it anyway. It's a good habit. 0 plus 6 is 6. Negative 6 plus 3 is negative 3. So we have 6 squared and negative 3 squared. 6 squared is 36. And negative 3 squared is 9. Radical 45. So can I write that any sloppier? Jeez. Radical 45. So the distance between these 2 points is the square root of 45. And if you had to estimate that, you'd have to understand that that's between radical 36 and radical 49. In other words, it's between 6 and 7. And it's probably closer to 7, right? Just judging by where 45 is in a number line in relation to 36 and 49. So yeah, it's between 6 and 7, closer to 7. Cool. Let's do another one. Let's do number 5. So we're going to write x1. I'm not going to do the colors because it was too complicated. x2 and y2. I will write the formula though. D equals x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. D equals x sub 2 is 3 minus x sub 1 is 8. Y sub 2 is going to be negative 3 minus y sub 1 is negative 7. 3 minus 8 is negative 5. And negative 3, almost forgot. Rewrite that like I just said. So negative 3 plus 7 squared. We'll go ahead and make that 25. That's going to be negative 3 plus 7 is going to be plus 4 squared. And 4 squared is 16. So 25 plus 16 is going to be 41. Yeah, 41. Radical 41. So that's in between radical 36 and radical 49. And this one's slightly closer to 6, so that would actually be closer to 6 and 7. Okay. So those two problems are, we did a bunch of these in class, but that way, hopefully, if anybody still has lingering questions, that hopefully answers it. Let's look at some of these ones that were down here. So I received some questions on these. So there's two ways to solve this, okay? You can, and this illustrates what I was trying to say but failed horrifically in the beginning, is, okay, so we have a line segment, right? We're looking for this value. This is the distance. This is what we were solving for earlier, but this is a visual representation of it. There's two ways to solve this when you're given a grid, okay, when you're given a Cartesian plane like this. You can simply find the x and y values, so this is -5, 1, right? And this would be 5, -1. And you could go ahead and solve these. You could say, okay, x1, y2, x1, y1, x2, y2, plug it into your formula and solve it. You could totally do that, which we just did. Or you could use the trusty Pythagorean theorem. You could create a right triangle here, and you could calculate. So we know this is going to be 2. This is going to be 10. That would be our A, that would be our B. We go ahead and solve that. So we're going to go ahead and set that up. So we're solving for the C, obviously. So it'd be 2 squared plus 10 squared equals C squared. 4 plus 100. 104. What does not? Jeez, what is wrong? There we go. 104. There we go. C squared. And then we can go ahead and take the square root because we want to get C, not C squared. So C would be equal to radical 104, or just over the value of 10, and that'd be the range of that. The length of that. So that's basically how you do those. Let's do one more, because I know there are some folks that were really confused by these. I'm going to go ahead and use the Pythagorean theorem on these because I just think it's way faster. So, and we already did 2 of the other ones anyway, so we're going to create a right triangle. Okay, so that's 4. And this is 7. Let's double check that. 1, 2, 3, 4, 5, 6, yep, 7. So we have 4 and 7. We're looking for this. So A and B. So 4 squared plus 7 squared equals C squared. 16 plus 49 equals C squared. And that's going to be 65, I think. Yeah, 65. Go. And then square root both sides. So this is just over the value of 8, right? Because we know radical 64 is 8, so this is just over it. And that's it. So I hope that clarifies any questions you may have had on this assignment. If you're still confused, please let me know. I'm more than happy to help. All right, thanks, guys.